Students, now we will start seventh sum, that is simplify and express as positive indices. We will give the answer in that power should be positive. Indices means power. So that power should be positive. So first part is a raised to the power minus 2, then b whole square power minus 2 multiply ab whole raised to the power minus 3. So how we will solve? First of all, we will see that we can write a minus 2 then b of same power. We cannot write. So first we will multiply the powers. So a raised to the power minus 2. Then this minus 2. So 2 2s are 4. A raised to the power 4. 2 2s are 4. Minus minus plus 4. A 4. Then about b, b raised to the power minus 2. Here power of b is 1. Then 2 1 are 2. Plus minus minus 2. Then this multiply. Now about this a raised to the power minus 3, b raised to the power minus 3. 1 3 are 3 plus minus minus. 1 3 are 3 plus minus minus. Now about this a raised to the power 4. It is also a and it is also a. They both are a and having power 4 and are in multiply also. And here power 4 and here minus 3. So we can add these two because they are in multiply. So 4 plus then minus 3. 4 plus we have to add minus 3. That's why we will write minus 3. Take this minus 3 inside the bracket. Then multiply b raised to the power minus 2. Then plus what we will add in this? We will add minus 3. It will come inside the bracket. Then a raised to the power 4 plus minus minus 3 multiply b raised to the power minus 2 plus minus minus 3. So we will solve this. So a raised to the power 4 minus 3 1. No need to write 1. Then b raised to the power minus 2 minus 3 means minus 5 because minus minus plus which sign will come? Minus sign 2 plus 3 5 then minus 5. What is the question? Express as positive indices. Now here indices is minus 5, that is negative. So we will express this positive. So it means a upon b raised to the power 5. B raised to the power minus 5 means 1 upon b raised to the power 5. So a upon b raised to the power 5. It is the answer. Now students, second part. In this 125 a raised to the power 3 upon 6 then whole power minus 1 upon 3. So first we will see that can we write 125 as power 3? Yes, we can write 5 raised to the power 3 means 125. A raised to the power minus 3, this also we can write. But we will take this power positive first. Then y raised to the power 6, this also we can write as power 3. See how? Y raised to the power 2, then power 3, it means y raised to the power 6. So all the numbers or variable a or either 6, y, we can write as power 3. So first we will take this a raised to the power minus 3 in denominator because power of a is negative. So 125 upon y raised to the power 6 then a raised to the power 3 then its whole power minus 1 upon 3. So first we will write 125 as power 3. So 5 raised to the power 3. Then about this y raised to the power 2 then a then whole power 3. See, when we will open this we will get 5 raised to the power 6, 3 to the 6, then a raised to the power 3. It is same. y raised to power 2a, then whole power 3. Then its whole power minus 1 upon 3. This minus 1 upon 3. So both the powers are same. So we can write a single power. It means 5 upon y square a, then whole power 3. See, both the powers are same. So we can write 5 upon y square a, whole power 3. Then its whole power minus 1 upon 3. Now we will do the multiply of powers. Here we will use power law. So 5 upon y square a, then 3 multiply minus 1 upon 3. So 3 banda 3. So 5 upon y square a, then whole power 1 banda 1 plus minus minus 1. Now you can see its power is negative. Then we will do the reciprocal. So y square a upon 5. Then no need to write power 1. So y square a upon 5 is the answer. That, see, first we will write 5. First we will take this a raised to power minus 3 in denominator. After taking this, we will write 125 as 5 raised to the power 3 upon y square a whole power 3. And both the powers are same of numerator and denominator. So we can write as single power. So 5 upon y square a, then whole power 3, and its whole power minus 1 upon 3. Now we will do the multiply of powers. That is coming 3 multiply minus 1 upon 3. 3 1 the 3. Then 5 upon y square a whole power minus 1. So power is negative. We will do the reciprocal of base. So y square a upon 5 is the answer. Xy raised to the power m minus n multiply yz raised to the power n minus l multiply zx raised to the power l minus m. So first we will write this base and power separately. This base and power separately, then rest also. So x raised to the power m minus n multiply y raised to the power m minus n multiply y raised to the power n minus l multiply z raised to the power n minus n. Then this also multiply z raised to the power l minus m multiply x raised to the power l minus m. Now the bases are in multiply and powers are also there. So this x base, see any other x base? Yes, this one. So we can write x raised to the power m minus n plus l minus m. We can write like this. We can add the powers. So it is written like. So about y, multiply y raised to the power m minus n, any other y? Yes, plus n minus l. N minus l. About z, multiply z, this z, n minus l, any other z? Yes, this, plus l minus m. So see, x raised to the power m, this negative m. So positive and negative m cancel. What is left? Minus n plus l. Then y, any other? M, not any other m. Minus n plus n cancel. So what is left? M minus l multiply z, n, any other n? No. Then minus l plus l cancel. What is left? N minus m. So it can be the answer. X raised to the power m minus n plus l multiply y raised to the power m minus l multiply z raised to the power n minus m. But what is better? take this minus n after L. It is better. So we will take that. So L is positive, then minus n. Then multiply y, m minus n. Multiply z, n minus n. So the answer is x raised to the power L minus n multiply y raised to the power m minus L multiply z raised to the power n minus n. Its sum show that x raised to the power a upon x raised to the power minus b then whole power a minus b. Multiply x raised to the power b upon x raised to the power minus c whole power b minus c. And multiply x raised to the power c upon x raised to the power minus a whole power c minus a. We will show this is equal to 1. After solving this, we will show is equal to 1. See how. X raised to the power a upon x raised to the power minus b. Bases are same. What about the powers? Powers can be subtracted. So x raised to the power a minus. For this divide minus. What we will subtract? We will subtract minus b. It will come inside the bracket. So x raised to the power a minus what we have to subtract minus b. Then multiply. Here also same. X raised to the power b minus what? Minus c. Then here we will take whole power a minus b. This. And here also b minus c. Then multiply x raised to the power c minus minus a inside the bracket. Then whole power c minus a is equal to 1. So x to the power a minus minus b is minus b. In the same way this, then b minus c. In the same way this, c minus a is equal to 1. Now we will solve this power bracket. So x raised to the power a minus minus plus b. Then a minus b. Once again multiply x raised to the power b minus minus plus c. Then whole power b minus c. Then multiply x raised to the power c plus a minus minus plus a. Then whole power c minus a is equal to 1. Now we will do the multiply of these powers. X raised to the power a plus b, a minus b. We will do the multiply a plus b, a minus b. It means a square minus b square. So a square minus b square. Then multiply x, b plus c, b minus c, b square minus c square. Multiply x, c plus a, c minus a, c square minus a square is equal to 1. Now all the bases are same. So we can add all the powers. So x raised to the power a square minus b square plus b square minus c square plus c square minus a square is equal to 1. So a square, any other a square? Yes, negative a square. This one is positive, so cancel. Minus b square plus b square cancel. Minus c square plus c square cancel. It means x raised to the power 0 is equal to 1. So x raised to the power 0 means 1 is equal to 1. So proved. You can see LHS is equal to RHS. 1 is equal to 1. 9 question. Evaluate. X raised to the power 5 plus n multiply x raised to the power 2 then whole power 3n plus 1 upon x raised to the power 7n minus 2. So all the bases are x. They are in multiply and divide. So first of all, this we will solve by using power law. So x raised to the power 5 plus n multiply x raised to the power 2 3s are 6n. First time we will multiply with 3n, then multiply by 1. So 2 1 the 2 plus 2 upon x raised to the power 7n minus 2. Then they both are in multiply, so we can add the powers. So x raised to the power 5 plus n plus 6n plus 2. 5 plus n plus 6n plus 2 upon x raised to the power 7n minus 2. Now we will solve this power. So x raised to the power 5 plus 2 7. 5 plus 2 7 plus n plus 6n plus 7n upon x raised to the power 7n minus 2. Now you can see both the bases are same and they are in divide. We can subtract the powers. So x raised to the power 7 plus 7n minus this power 7n minus 2. And it is compulsory to take this inside the bracket because here is minus sign. Here was plus sign. We had not taken inside the bracket, but in minus sign we will take inside the bracket. So we will solve this. X raised to the power 7 plus 7n minus plus minus 7n minus minus plus 2. Now x raised to the power 7, any other number? Yes, this 2, so 7 plus 2, 9. 7n minus 7n cancel. So answer is x raised to the power 9. 10th sum. Prove that m plus n whole power minus 1, then bracket close, then inside the bracket m minus n, m raised to the power minus n plus n raised to the power m raised to the power minus 1 plus n raised to the power minus 1 inside the bracket is equal to mn whole power minus 1. So you already know that between the brackets multiply sign is here. No sign, it means multiply sign. M plus n whole power minus 1. So we can write 1 upon m plus n because of this negative power. Then multiply, take inside the bracket 1 upon m because m raised to the power minus 1. We can write 1 upon m plus 1 upon n. Then is equal to mn power minus 1. So we will solve this by taking the LCM. So 1 upon m plus n multiply LCM of m and m, LCM of m and n, m. Now we will divide m to m cancel, n multiply 1, n. In the same way here also n to n cancel, m multiply 1, m is equal to mn raised to the power minus 1. So 1 upon m plus n multiply n plus m upon mn is equal to mn minus 1. n plus n plus m cancel. So 1 upon mn is equal to mn whole power minus 1. Here is 1 upon mn. So we can write mn whole power minus 1 is equal to mn whole power minus 1. So for 1 upon mn we can write mn whole power minus 1 is equal, it is already mn whole power minus 1. Now both LHS and RHS equal, so true. Question. Find the value of n when first part a raised to power 2n minus 3 multiply a raised to power 2 bracket close, then power n plus 1 upon a raised to power 4 then whole power minus 3. Then it is given in RHS also. So we will solve RHS and LHS both first by using power law. So a raised to the power 2n minus 3 multiply a raised to power 2, then multiply n plus 1. So 2n plus 2. 2 multiply n 2n and 2 multiply 1, 2 1 the 2 upon a raised to the power 4 3 is 12 minus 12 plus minus minus 12 is equal to a raised to the power 3 3 is 9 divide a raised to the power 6 3 is 18 minus 18 because plus minus minus 18. Now they both are in multiply, bases are same, so we can add the powers. So a raised to the power 2n minus 3 plus 2n plus 2 upon a raised to the power minus 12 is equal to a raised to the power 9. They both are in divide, bases are same, so we will subtract the powers. A raised to the power 9 minus minus 18 inside the bracket. So a raised to the power 2n, here also plus 2n, so it will become 2 plus 2n plus 2n 4n minus 3 plus 2 minus plus minus 3 minus 2 1, 3 is greater having minus sign, so minus 1 upon a raised to the power minus 12 is equal to a raised to the power 9 minus minus plus 18, 9 plus 18. So now you can see here bases are same, they are in divide, so we can subtract the powers. So a raised to the power 4n minus 1 minus minus 12 inside the bracket. So a raised to the power 9 plus 18 27. So a raised to the power 4n minus 1 minus minus plus 12 is equal to a raised to the power 27. So a raised to the power 4n minus 1 plus 12 plus 11 is equal to a raised to the power 27. Now bases are same, they are in equal, so on equalizing the bases we can write 4n plus 11 is equal to 27. 4n plus 11 is equal to 27. So 4n is equal to 27 minus 11. 4n is equal to 16. So n is equal to 16. It will move to RHS, changes into divide. So 4 4 the 16. So n is equal to 4. So value of n is equal to 4. Simplify. So in this first we will solve powers by using power law. So a raised to the power 2n plus 3 multiply a raised to the power 2n multiply this n. Binomial multiply binomial. This I told you in class 7. 2n multiply this n. 2n square. Then 2n multiply this 2. One time with this n, one time with 2. So 2 2s are 4n plus 4n. Now by 1. 1 multiply this n. So 1 multiply n plus n. Then 1 multiply this 2. So plus 2. 2n multiply this n, 2n square. 2n multiply 2, 2 2s are 4n. 1 multiply n, 1. 1 multiply 2, 2. Upon a raised to the power 3 2s are 6n. Then 3 1 the 3 plus 3. Multiply a raised to the power n multiply 2n. 2n square. Then n multiply 1 plus n 1 the n. Now we will solve this 4n plus n first. So a raised to the power 2n plus 3 multiply a raised to the power 2n square 4n plus n plus 5n plus 2 upon a raised to the power 6n plus 3 multiply a raised to the power 2n square plus n. After solving this 4n plus n 5n, we will add the powers. See, they both bases a are in multiply, so we can add. Here also they both are in multiply, we can add these. So a raised to the power 2n plus 3 plus 2n square plus 5n plus 2 upon a raised to the power 6n plus 3 plus 2n square plus n. So a raised to the power 2n, any other n, only n, 5n. So it will become 7n plus 3, any other number, yes, 2. So 3 plus 2, 5. Then only this one is left, plus 2n square upon a 6n, any other number, n, yes, plus n. So 7n plus 3, any other number, no, so plus 3, then plus 2n square. Now you can see both the bases are same and they are in divide, so we can subtract the powers. So a raised to the power 7n plus 5 plus 2n square, then minus this power, minus inside the bracket 7n plus 3 plus 2n square, bracket close. So a raised to the power 7n, now we will open the bracket, plus 5 plus 2n square minus plus minus 7n minus plus minus 3 minus plus minus 2n square. Now we will solve this power. So a raised to the power 7n minus 7n cancel, plus 5, any other number, yes, minus 3. It means 5 minus 3, 2. So plus 2n square minus 2n square cancel. So the answer is a raised to the power 2. It means a square.